word to Johan De Boever of ILVO. He is a feed and chemical analysis expert and will talk about the application of NIRS in animal production. So, Johan, the floor is yours.
Good morning, everybody. I will speak about the application of NIR in animal production. NIR is mainly used for feed evaluation, and an accurate and fast feed evaluation is very important to meet the nutrient requirements of high-producing cows, pigs, and poultry for optimal performances and health of the animals, for the income of the farmers, and also to limit the emissions and excretions into the environment. NIR is used to evaluate the quality of forage crops, but also of silages on the farms, as well as for raw materials and compound feeds in the feed factories. Further, NIR can also be used to evaluate the quality of end products like milk and meat, as well as for feces. We started at ILVO Animal Sciences in '89 with a scanning monochromator in the wavelength spectrum from 1100 to 2500 nanometer. In first instance, to develop calibrations for compound feeds for ruminants. We worked together with members of the Belgian Feed Association, which at that time disposed of filter instruments. And we developed calibrations for 18 feed ingredients, of which calibrations were transferred from our instrument to their instruments. We also developed calibrations for grass and maize silage, and we used the instrument as well for predicting fat and protein content of milk of individual cows in our feeding experiments. We used NIRS also for predicting composition of cattle meat. Some years ago, we bought a new instrument with a larger wavelength range, and we used that instrument to predict composition and quality of pig feeds, as well as for pig feces. And we tried to combine spectra from pig feed with that of pig feces in order to have a better prediction of the quality. We further used the instrument to predict residual digestibility of cattle feces, as well as to predict intramuscular fat of pig meat. With this slide, I want to give some idea of the prediction ability of NIR for chemical composition and feeding quality. So therefore, for calculating the prediction ability, we calculate the ratio of the standard deviation of the parameter in the data set on the standard error of the prediction with the calibration. So when this ratio is higher than 3, we can assume that the calibration is accurate. When the ratio is between 2 and 3, the calibration is of moderate accuracy. When the ratio is lower than 2, the calibration is of less use. For example, here for crude S, while we obtain a good prediction for moisture, protein, fiber, and fat in feeds, and for digestibility and net energy, the quality of the prediction is moderate. Besides the use of NIR for quantitative analysis, we can also use NIR for qualitative purposes. And here in this case, we scanned different feedstuffs, and based on using principal component analysis, we could discriminate between starchy and protein-rich feeds by plotting principal component 1 with principal component 3. In that application, we try to predict total and phytate phosphorus in feedstuffs. Besides, also on the ILVO Plant Sciences unit, NIR is used for variety testing and for breeding of forages. They also have already a long history of instruments, and they use their calibrations, NIR, to predict the feeding quality of different products, forage maize, for example, grass clover, as well as for soybeans. Besides the use of NIR in the lab offline, NIR can also be used online, and therefore they equipped their Haldrup harvesters for experimental fields with an NIR instrument, and they only use it for the moment to predict the moisture content. The instrument is mounted in the top of the cabin, and the scanner is on the grass flow. There are a lot of disadvantages because the grass contains a lot of water, and the strong water peaks mask the signals of the other instruments. Okay. Then also in a big breeding company, NIR is used online on harvest machines, but important is to mention that they developed a portable mobile lab, which is used to evaluate fresh and inside paste and grass on the farm. Another application is in a big forage testing lab, where they have a Fourier transformed NIR instrument, which enables to scan the samples in the bottle, and they develop calibrations by local weighted learning. This instrument is in Wageningen, this Eurofins, and is connected in a network with different clients, for the moment 19 laboratories, which send their spectra to the central lab, which give then a recommendation within 4 hours to the clients. This in that Eurofins is also used for soil analysis and also now for grass silages without drying and grinding by using a handheld scanner. Last, the NIR is used for process quality control of compound feeds, for example, in Van den Avenne, where they use NIR in line, where the instrument is mounted on the bunker under each mixer, and they use this instrument for troubleshooting, also for giving documentation on their batches. But interesting is that they measure water activity, a parameter which is important for the storability of the feed, and so they can dose organic acids during the process, and this controlled dosing saves money and provides a consistent product quality. They also combine NIR data with data from the mixing lines, with the data from the presses, in order to control the energy consumption of the presses. And in the last step, they want to use NIRS online at the reception of the raw materials, possible because they have calibrations on ungrown samples to manage the matrices in real time. And I want to end my speak with some points of attention. It is important to create a large database, to take care of reproducible reference analysis, to be aware that a scanned sample is not always similar to the analyzed sample, that it is important to develop and update your own calibrations, to regularly validate your results, to check frequently your instrument with a reference sample, and it is less suited for micro constituents and anorganic elements. Thank you.